Hello everyone. Before starting the lesson, try this warm-up. Bob put $500 into an investment that earned 6% annual simple interest. What was his investment worth after 5 years? This relates back to the previous lesson, so pause the video and try this on your own. I can use the simple interest formula. I equals PRT. The principal was $500. That's what he started with. The interest rate was 6%, and he left it in the investment for 5 years. 500 times 0.06 times 5 is 150. So that's how much interest he earned in the 5 years. But what was his investment worth? It wasn't worth $150 because he put $500 into the investment originally. So to find the total amount, we're going to add the principal and the interest together. We get a value of $650 after 5 years. In this warm-up, we talked about simple interest, and that was what we talked about in the previous lesson. But in this lesson, we're going to look at compound interest. You'll be able to solve problems involving compound interest. So I want to remind you first what interest is. It's the cost of borrowing money. So whoever's doing the borrowing has to pay back this extra cost, the interest. So when you borrow money from the bank, you pay the bank interest. When you put money in the bank owes you interest. And there's two types of interest, simple interest and compound interest. In the previous lesson, we looked at simple interest, and this is what we calculated in the warm-up. The interest is calculated only on the original amount borrowed. Whereas with compound interest, interest is calculated on top of interest already earned. Now, before I get into an example of compound interest, let's start by just reviewing a simple interest example. Bob borrowed $1,000. That's the principal. The bank is charging 10% simple interest per year. That's the interest rate. So we're borrowing $1,000. The interest rate is 10%. So we use our I equals PRT, and we find that there's $300 in interest. So the total amount he has to pay back is the $1,000 plus the $300 in interest. We get a total of $1,300 that he has to pay the bank. Now let's switch to the other kind of interest. We're going to talk about compound interest now. Bob borrowed $1,000. That's the same as before. The bank is charging 10% annual interest. That's the same. However, this is different. It's compounded annually. This means that interest is charged every year on top of the interest charged in the previous year. So how much money will Bob owe when he pays back the loan 3 years later? This is the same question that I asked in the simple interest example, but this time the interest is being compounded annually. I'm going to illustrate this with a chart. In the first year, he owed $1,000 at the start because that's how much he borrowed. The bank charges 10% interest for that year, so they charge him $100 in interest for the first year. So at the end of the year, he owes a total of $1,100. So at the beginning of the second year, he owes $1,100. But this time, the bank is going to charge him 10% of that amount. So 10% of that $1,100 is $110. So in the second year, he owes $110 more in interest for a total of $1,210. So at the beginning of the third year, he owes $1,210, but the bank is going to charge him over that year 10% of that, which is $121 in interest. So add that to the amount he owed, and now it's up to $1,331. I don't know if you remember the simple interest example, but he borrowed $1,000. He was charged 10% annual interest, and he paid it back 3 years later. But for the simple interest example, he owed $1,300. In this compound interest example, he owes $1,331. So he owes more interest when the interest has been compounded. Well, that makes sense because they're charging interest on top of the interest they charged in the previous year. Now, this is the chart that I just showed you. I want you to notice a shortcut. From the start of the year to the end of the year, I'm adding 10%. That's the same as multiplying by 1.10. And if I do that every year, I'm multiplying by the same amount multiple times. Repeated multiplication can be simplified by using an exponent. So I'm starting with $1,000. I'm multiplying it by 1.10 3 times. So that can be written like this. This is your principal. This is 1 plus the interest rate. And the exponent is the number of times you're multiplying by that interest rate. So I can avoid writing out a chart like this when it comes to compound interest examples, and I can rely on a math equation instead, which can save me time. And this is the equation. You should write this down on your unit summary sheet. A represents the total amount you owe. Call it the total amount or the future value. P is the principal or the present value. In brackets, that's 1 plus the interest rate, but it's a little bit different. This isn't the annual interest rate. This is called the interest rate per compounding period. I'll illustrate what that means with examples. And N is the exponent. This is not the number of years necessarily. It's the number of times the interest is being compounded, or we can call it the number of compounding periods. So make sure you have this formula on your summary sheet with the definitions of what the different letters represent. So let me walk you through an example of compound interest. Roberta borrows $2,500 and will pay it back 5 years later. The annual interest rate is 12%. What would be the total amount owing for each compounding frequency? In the example I already went through, the interest was compounded annually. That means once every year. However, you can compound the interest more frequently than that. For example, annually versus monthly. I'm starting with the same formula. The amount of money is equal to the principal multiplied by 1 plus I to the exponent n. The principal is $2,500. But notice, the other numbers are different. Why are they different? The interest rate is 12%. If you're compounding annually, that's once per year. So if you divide the annual interest rate into one piece, it's 12% every time you compound the interest. Whereas over here, if we're compounding the interest monthly, that means they're going to charge me interest every month. So if the annual interest rate is 12%, but you're calculating the interest every month, then every month is going to be 1%. Do you get it? 12% for the entire year divided by 12 months in a year, that's 1% each month. So we're dividing the annual interest rate by the number of times we're compounding the interest in a year. This, in effect, is the monthly interest rate down here. Similar with the value of n. N is not necessarily the number of years. We're paying back 5 years later. N is the number of compounding periods, though. So, in the first instance, interest is being compounded once per year. So if you're compounding the interest once every year for 5 years, that means you're compounding the interest 5 times. Over here, you're compounding monthly. That means you're compounding the interest 12 times every year for 5 years. 12 times 5 is 60. So overall, you're going to compound the interest 60 times. So if you plug in those numbers, you get these answers. Notice the total amount owing is different. If they're compounding the interest annually, you'll pay less interest than if they compound the interest monthly. I can also compound the interest weekly or bi-weekly. Weekly means every week. There's 52 weeks in a year, so we're going to compound the interest 52 times every year. Bi-weekly means every other week. So that would be only 26 times a year. So this is the calculation we would do. I is the annual interest rate divided by the number of compounding periods in a year. N is the number of years multiplied by the number of compounding periods in a year. Try these in your calculator. If you're not getting these answers, you should reach out for help before moving on. Or if there's any confusion at all about where the values for I and N are coming from, reach out before moving on. The other thing too is that these words, annually, monthly, weekly, bi-weekly, they appear on the bottom of your unit help sheet with numbers. And the numbers are how many times a year that corresponds to. So annually is 1, semi-annually is 2, quarterly is 4, monthly is 12, etc. So you have those numbers available so you don't forget them. Here's the next example. Calculate the total amount owing for each loan. So total amount owing, you're calculating A. In the first instance, you're borrowing $10,000 for 6 years. Same with the second instance, you're borrowing $10,000 for 6 years. They both have the same annual interest rate of 6%. For the first one, we're compounding monthly. For the other one, we're compounding semi-annually. So pause the video and calculate A for each of these loans, and then check back in to see how you did. So here we are. We're starting with the same principal. It's the same annual interest rate. We're just dividing that by different amounts. Monthly means we're dividing that annual interest rate by 12 to get the monthly interest rate. Semi-annually means we're dividing that annual interest rate by 2. N is 72 in the first instance because 12 times a year for 6 years, 12 times 6 is 72. And for the next one, semi-annually is twice a year for 6 years. That's 12 times total. So if you plug those into your calculator, that's the answer you get. So when you borrow $10,000, you're either paying this much or this much, depending on how much compounding is happening. Now here's a follow-up question. How much interest was charged for each loan? We're borrowing $10,000 and you're paying back this much total, so how much interest was charged? Well, if you borrowed $10,000 and you paid back $14,320.44, that means you paid back $4,320.44 in interest. That $10,000 of that amount you're paying back was the principal. Only this much was the interest. So I wrote another little equation here. The amount of interest is equal to the amount minus the principal. And I can do the same thing over here. I ended up paying $4,257.61 in interest on top of the $10,000 borrowed to get a total of this much. Now we're still talking about compound interest. This is the formula that I went through earlier to calculate the amount you have to pay back. But I could rearrange this formula to solve for the principal. And it would end up being this. Notice there's a negative exponent now because we're looking backwards in time to what the starting amount was. So the letters represent the same things. It's just we've rearranged the equation to solve for the principal instead. So here's an example. Biff's savings account earns 3% annual interest, compounded monthly. He wants to have $2,000 saved in 5 years from now. How much should he invest today to reach his goal? So the picture is, he wants to have this much money, $2,000 in 5 years. He wants to know how much to put in his bank account now so that by the time the interest grows in his bank account, he will have $2,000. So this $2,000 is the future value. This is the value he wants to have at a later date. This is A. How much should he invest today? Well, that's the principal. That's the present value. That's how much he wants to put into the account today. So we're going to use this formula to solve for the principal. Put in the future value he wants to have. I and N represent the same things as they did before. So if the annual interest is 3% and it's compounded monthly, then I is 3% divided by 12. N is the number of compounding periods. So if it's compounded 12 times a year for 5 years, 12 times 5 is 60, N is 60. But just remember, the exponent is negative. So when you type this in your calculator, remember the negative exponent. He should invest $1,721.74 today so that 5 years from now, he will have that $2,000 that he wants to have. Brenda's account has an annual interest rate of 2.25% compounded weekly. How much does she need to deposit now in order to have $1,200 in 7 years? This is like the previous example, so pause the video and try this one on your own. The future value is 1,200, that's A. The annual interest rate is 2.25%, which is 0.0225. It's compounded weekly, so divide that interest rate by 52. And we want this amount of money in 7 years. So if it's compounded 52 times a year for 7 years, 52 times 7 is 364. When you type this in your calculator, remember the negative exponent, you end up with $1,025.17 as the principal. That's how much should be invested today in order to have $1,200 in 7 years. Now let's try some slightly different questions. What annual interest rate, compounded monthly, will be required for $500 to grow to $1,200 in 11 years? So we can use the compound interest formula, but this time we're trying to figure out what the annual interest rate is. So I'll start with my compound interest formula, plug in the numbers that I know. A is $1,200, that's what it's going to be at the end of the time period. P is $500, that's the amount of money at the beginning of the time period. I don't know what the interest rate is, so I don't know the value of I, but N, I do know, or I can figure it out. The investment's going to happen for 11 years, but N is not 11 because the interest is being compounded monthly. So N is the number of months. Well, 12 months every year for 11 years, 12 times 11, that's 132 months. So I know all these numbers. Now I can start solving for I. If I divide both sides by 500, I end up with this. 2.4 equals 1 plus I to the exponent 132. Now just as a side note here, if I had an equation like this, 9 is equal to x squared, to figure out what x is, I would do the square root of 9 to figure out what x is. Now if you recall, square root is the same as an exponent of 1 over 2. Now I bring this up because I can do a similar thing here. I don't know what the base of this power is, but I know when it has the exponent 132, I get an answer of 2.4. So just like to solve for x here, I did the square root or exponent of 1 over 2. If the exponent's 132, I can do the exponent of 1 over 132. So to get rid of the exponent on the right side, I have to take the exponent of 1 over 132. So if I do that in my calculator, I can just type 2.4, hit my exponent button, and then in brackets, 1 divided by 132, which gets me 1.00665 approximately. And if I want to know what I is, subtract 1, I is this, 0.00665. But remember, I is not the annual interest rate. It's the interest rate per compounding period. The compounding periods are months. So if I want to know the annual interest rate, I need to multiply this by 12. So when I do that, I get about 0.0799. That's about 7.99% as the annual interest rate. So you can actually figure out what the interest rate is if you know what you're starting with and what you're ending with, and the amount of time and the compounding frequency. The key thing here, if you want to undo an exponent, turn it into a rational exponent like I did here. Here's the next example. Bertha put $800 into an account that earned 6% per year, compounded quarterly. When she took her money out, she had $1,110.05. How long was the money in the account? So this time, we know what we're starting with, we know what we're ending with, we know the interest rate, and we know the compounding frequency. We just don't know the amount of time. So this is what we have. Compound interest formula. We know A is $1,110.05. We know P is $800. We know the interest rate was 6% per year, compounded quarterly. So I is 0.06 divided by 4. We don't know what N is. And when we talked about exponential functions, when we were trying to figure out what the exponent was, we used the method of guess and check. So we try different values of n and see what gets us the right answer. And I've done this ahead of time. I know when I use a value of 22 for the exponent here, and I do this calculation, I get approximately this. So that value is pretty close. Now let's answer the question, how long was the money put in the account? Is it 22 years? No. Remember, n is the number of compounding periods, and it's compounded quarterly. That means 4 times every year. So we need to figure out how many years it is based on the fact that there's 22 compounding periods. Each compounding period is 1/4 of a year. So if I take my number of quarters and divide by 4, that tells me this was about 5.5 years. So to grow your money from $800 to $1,110.05, we had the money in the investment for 5.5 years. So in this lesson, we compared simple interest with compound interest. You have 2 formulas for compound interest. One is for solving for A, one is for solving for P. When you read the question, you need to figure out what are you trying to find, A or P? The future value or the present value? That determines which equation you're going to use. Now, I also gave you some examples where we're finding other values like the interest rate or the amount of time the investment happened, but you have strategies for all of those. So as you work on the practice for this lesson, reach out if you have any questions.